Alrighty guys, today I'm talking about section 8.6 in Algebra 2 and Trig, where we're solving rational equations. Just a reminder, there are now new notes on section 8.6 in the resource folder. That's new notes in the resource folder. So if you want them of your own, go ahead and print them out free of charge in the resources folder on the website. Alright, so let's take a look at what we're doing today. We're solving equations with fractions in them, right? Well, to solve an equation with fractions in them, and again, these notes are more detailed online if you want step-by-step procedures, but ultimately, I want to get rid of the fractions. I know that fractions make our life harder. Don't think I don't, because I know they do. So my goal is to get rid of the fractions. So I'm going to use a rule that I've outlined in depth in those notes on 8.6. Well, the first thing I need to do is find out what my LCD is. Well, let's take a look at this. Well, let's see. In the first fraction, I see an x plus 1. So I know that he has to be in my LCD. For 3, he's got a denominator of 1. Now, 1 is, even though that's a denominator, I don't really care about him. And then lastly, the last fraction is an x plus 1. Well, he's already got an x plus 1 in the list of LCD, so I don't need to change him, all right? Or I don't need to add that x plus 1 into the list. All right, so this is my LCD. My goal is I'm going to take all the terms in that equation and make them all have the same LCD. Well, let's see. The first term, the 2 over x plus 1, he already has an x plus 1 in his denominator. He doesn't need anything. Now, the 3, he needs an x plus 1. So I need to give his bottom an x plus 1. But if you remember, if you do something to the bottom of a fraction, you have to do the same thing to the top. Okay? Now, he's a term that has an x plus 1 on his bottom. And then lastly, the last fraction, the 4 over x plus 1, he already had an x plus 1 on his bottom. He's good to go. Now, the beauty of this method is, if you can make each term have the LCD, or make them have matching denominators, you actually just get to cancel out those denominators and write a new equation from only the numerators. So I can create a new equation that says simply 2 plus 3 parentheses x plus 1 equals 4. Okay? By canceling out those denominators, notice I don't have an equation with a fraction in it anymore. This is a pretty basic equation to solve. At this point, I can just say 2 plus 3x plus 3 equals 4. Combining like terms, I get 3x plus 5 equals 4. Subtracting the 5 across, I get 3x equals negative 1. Divided by 3, I get x equals negative 1/3. So the answer to this equation is negative 1/3. Now, you do have to make sure, because we have an x in the denominator of a fraction, you got to make sure that whatever answer I get for x wouldn't give me 0 in that denominator. If I plug this negative 1/3 in right here, if I plugged him into the equation, if I plug in that negative 1/3, here and here, would either of those denominators become 0? I think not. Therefore, I know that I'm good to go. The negative 1/3 is a golden answer. Okay. And that's how we solve that. Let's take a look at another example. All right, in this one I've got 3 over 2x minus 5 over 3x equals 2. Again, I'm going to make my LCD. Now notice, none of those denominators can factor, so my LCD, the least common denominator between 2 and 3 is 6, and between x and x is x. My goal is to make all of these bottoms turn into a 6x. Well, let's see here. The first fraction, what does he need if I wanted him to become a 6x? He just needs 3, so I multiply the bottom by 3 and the top by 3. The second fraction, he needs a 2. So I need to multiply his bottom by 2 and his top by 2. And the last fraction, the 2 over 1, well, he needs both the 6 and the x. So I multiply top and bottom by 6x. Okay? Now that I've made everybody have a 6x on their bottom, I cancel those out. And I'm just left with, well, I'm going to cut to the chase. It wouldn't have been 9 minus 10 equals 12x. Well, I get negative 1 equals 12x, so x must be negative 1/12. Now, before I put my box around this answer to say that I'm done, I just got to make sure that I wouldn't get a 0 in the denominator of any of those fractions. By plugging in a negative 1/12 here, that's okay, and negative 1/12 here, that's okay. So I know that negative 1/12 is a good answer. I'm done. All right, let's do one more example, and then we'll call it a day. All right, take a look at this last example here. This is a more complicated one. In this fraction, or in this equation, I've got x plus 1 over x minus 5 plus x plus 1 over x plus 2 equals 3 over x squared minus 3x minus 10. Now I look at this first bottom. He doesn't factor, so I don't have to worry about him. The second bottom, x plus 2, he doesn't factor, so I don't have to worry about him. But anytime I have a quadratic, I say to myself, oh, he might factor. Well, if you think about this, doesn't this factor into x minus 5 and an x plus 2 as a new bottom? Right? So now when I go to make my LCD list, I see the first bottom. I see that factor, I put them in the list. I see an x plus 2, I see it, I put it in the list. Now look at this last bottom, this last denominator. Would you agree that an x minus 5, this x minus 5, he already appears in the list here. So I don't need to write him twice. Right? Likewise with the x plus 2. Since there's an x plus 2 already in the list, I don't need to write him again. Don't forget that when you find an LCD, you should see each of the individual old denominators as some part of your list. And what I mean by that is, I see an x minus 5, oh, that's right there in the list. I see an x plus 2, oh, that's right there in the list. And I see an x minus 5 and an x plus 2, well, that is the whole list. So, as long as all the denominators are accounted for in the LCD, you know that LCD is a good LCD. All right, now, it's time to adjust. What does the first fraction need from that LCD list that didn't have? Well, I think it needs an x plus 2. So I put an x plus 2 on the bottom, and I put an x plus 2 on the top. The second fraction needs an x minus 5. So I give him an x minus 5 on his bottom and an x minus 5 on his top. And the last fraction, if you look at him, he actually doesn't need anything. He's good to go. 3 over x minus 5 and an x plus 2. Now, if you look, all the denominators are matched, so I can just draw a line and cancel them, right? So my new equation is simply x plus 1 times x plus 2 plus x plus 1 times x minus 5 equals 3. And I really should have put parentheses around these two like that. Okay? Now, to solve this, the first thing I got to do is I got to FOIL. I got to FOIL the first two parentheses. I'm going to get x squared plus 3x plus 2 plus, FOILing the second parentheses, set of parentheses, I get x squared minus 4x minus 5 equals 3. That's a quadratic, so I need to combine my like terms. I get 2x squared minus x minus 3 equals 3. Subtracting the 3 across, I get 2x squared minus x minus 6 equals 0. And then I hope that this guy factors. If he wouldn't factor, I'd have to either complete the square or use quadratic formula. Well, lo and behold, he does factor into a nice and tidy, let's see here, what multiplies to give me negative 12, that's to give me 1. A negative 1 is negative 4 and positive 3, so that becomes x minus 2 and 2x plus 3. So my answer from the first parentheses is x equals 2, and from the second parentheses, x equals negative 3 halves. Just making sure that neither of these values would give me 0 in the denominator. X, if I put a 2 in for this bottom, 2 here, 2 here, 2 here, 2 here, none of those become 0, so 2 works. And again, I think obviously, if you plug in, hopefully you can see that if I plug a negative 3 halves, which is negative 1 1/2, in for all those x's, none of those bottoms will become 0. So in this case, both those answers work. I get an x equals 2 and an x equals negative 3 halves. All right. Well, that's this section. Again, read over the notes, print them out, and we'll talk more about this in class tomorrow.